Okay, back with part two on this one. I investigated the geometry of this a little further, and like I was saying in the last video, although it was an illustration, it also had some very interesting and significant geometry in there. So I have explored this geometry a little further, and I have found a few more things and a couple of little extra tidbits. Yeah, just before I start here, I guess there's a couple of interesting things here. Just some get that to focus for people just into kind of like number stuff. Yeah, 13 times 13 is 169. 180 minus 169 is 11. 60 minus 47 is 13. 180 minus 47 is 133. 33 plus 14 is 47. 133 plus 14 is 147. 180 minus 147 is 33. So, just some interesting stuff here. And of course, the last one was the sides of the square. Each side is exactly a compass width of 47 degrees, which of course gives you a 7-point circle on a 22 diameter circle. So yeah, I was exploring this and I found some other interesting stuff in here where, boy, this focus is really having a hard time today. So from the point of that corner of the square to the corner of the triangle of 47 degrees, that measurement there gave you, or gives us, a compass measurement of 51.42, etc., which gives us a 7-point circle on a 24 diameter circle. So, another interesting measurement here. And there's, one of the sides of the square, which gave us the 47. So there's a 7 on the 22, there's a 7 on the 24, and from the corner of the triangle of 47 degrees to that point there, where the side of the square meets the bottom of that triangle, that measurement in there is exactly 20 degrees, which 20 into 360 gives us 15, so that's a 15-point circle on a 24 diameter circle. So there's another interesting measurement there. And then, since I found that other stuff last time, I started exploring from the corner of the square there, and when I started drawing these lines to those various points of the 14 points on the 22, I found, so that angle in there gives a perfect 90 degrees from that corner to two of the points on the 14-point circle. Those 2 points right in there from the corner of that square gives a perfect 45 degrees. And from that point to the corner to that point in there gives a perfect 72 degrees, and from where the diameter meets the edge of the 22 radius circle to that point there in here is a perfect 60 degrees. And there's a bunch of neat stuff going on there. And from that point there to the corner of that triangle is exactly 3 inches. I just happen to find that kind of interesting. And okay, so then we get into some more interesting stuff in here. From the middle of that square to the bottom points of that triangle, which was the perfect equilateral triangle. So from the middle of that square to that point, middle of the square to that point, that measurement, or that one, either or, on the compass gives us a measurement of 28 degrees on the protractor. See if I can quickly show that here. So you can see that, yeah? 28 degrees on the protractor, right? And that, as I found out, boy, this focus is just terrible today, gives us a 14-point circle on a 26 diameter, which is the outer diameter of this very geometry. Right, so that's really interesting. That measurement there gives 14 points on a 26 diameter circle. So that was a really cool find. And then I started to look around, what else was kind of neat. Yeah, I mean, first of all, going back to this, I mean, so you get 14 points, right, with 28 degrees. So, both of those, they belong to that family of 7, right? So that's just really interesting. And then while I was exploring the 26 diameter circle, I also found that 56 degrees gives us 7 points on a 26 diameter circle. So this that measurement right there. There to there. That's 56 degrees on a protractor. And that just happens to give you 7 points on a 26 diameter. 56 degrees. And that's, that's very interesting too, because just for still with this kind of theme here with the 7, 11s, and 22s. And so, 56, the 5 and the 6, it gives you that 11 kind of thing. But I don't know, maybe that's significant, maybe it's not. And that one I just showed, I'm going to get to this in a moment. So just want to go over here in case I missed something. No. Okay, so let's go back to... So as I mentioned a couple of videos ago, a 21-point circle on a 24 diameter, that's another one that's quite difficult, because 21 into 360 is 17.14, 285, something like that, etc. Right? But then there was an easier way to do it, and what I found is that 20 degrees on a 28 diameter gives us a perfect 21 points. Otherwise, to get 21, you would have to draw a triangle in one of the circles, and then use one of the measurements of 7 and scribe from each point, each of those 3 points. You scribe 7, and then you get your 21. Yeah, but there's a way that's a very easy way to do it. So, anyways, I thought this was interesting. So this is the part 2 to this geometry here.